Okay. So this is the architecture diagram for Postgres. Okay, you can see the process, there's a post master process. Okay, so
Uh-huh.
whenever any connections coming to the Postgres, it will come through the post master process only. Okay, it will come through the
Uh-huh.
post master. Whenever somebody wants to connect, he will connect from the post master.
Uh-huh.
Okay, so he will connect to the postmaster. Assume this is the connection, so he will connect to the postmaster, and next the connect to the postmaster, then postmaster will hand over the connection to the shared memory. Okay, to the shared memory, the first connection that will come to the is postmaster. So any user connecting so postmaster is running on some particular port number. Okay, and it is kind of an listener as well. The role is listener as well, what is there in the Oracle listener. So postmaster role is something very similar to a listener process what we have in Oracle. Okay, but it is much above the listener. Okay, now let us maybe so I will want to explain both the ways, right? Somebody is an Oracle DB or not an Oracle DB as well. So if it's an Oracle DB, you can understand it's a listener. And the second thing, it is attached to one cluster, so one database cluster it's attached to. Okay, so you have one postmaster, your connection comes to the postmaster, then you hand over the shared memory. Now let us have a simple example. Okay, let us take a very simple example. Let's assume there is a table, a school. Okay, so I say select star from school. Okay, first of all, first of all, what will happen? First of all, he tried to connect. Okay, so I try to connect. I give the port number of postmaster. I provide the database name. Assume the database name is Postgres, and then
Uh-huh.
and I provide a database name, and then I provide port number. Port number is the port number of the Postgres, and I provide the host name. Okay, host name may be localhost. Assume. Okay, and then I provide the username and password. Maybe the username is maybe what do you say? User one. Password is, assume it is password. Okay. So what will happen in this P SQL? He will go to the postmaster. Go to the postmaster because he will go to the postmaster because this 5432 is the port number of this postmaster. Okay, so assume this postmaster is running in the port number 5432. So this is the port number of the postmaster. You'll go to the postmaster. He will say that I want to connect to the Postgres database. Localhost is the server name with the postmaster is running. If somebody wants to connect, he will put in the port number. He will put on the localhost, the server name, and the port number, and will provide the database name to it. So try to connect to the database with that user ID and password. So assume the connection is successful. So connection is successful. He will reach. He will go inside to this database. Okay, he will go inside to the database. Okay, into the database. Okay, he will go inside the database. The database is Postgres. Okay, database is Postgres. So once he postmaster hands over the connection to the database cluster, okay, to the database cluster, which is the database is Postgres. So what will happen next is he will create a process. Okay, he will create a process. He will create a process. This process is known as a backend process or a Postgres process. Now, this process will keep on communicating with the user and keep on satisfying all the information it needs. Okay. So the first query he put is select star from school. Select star from school. He put this query select star from school. Postmaster now postmaster job is done. He has already handed over the connection. Okay, now Postgres process, also known as backend process, will take care of this query select star from school. He will go to the shared memory. In the shared memory, he know that he have to search in the Postgres database. Okay, he will go to the shared buffer. He will go to this buffer, which is the shared buffer. Okay, he will go to this buffer. He will search for school. He will search for school. This arrow is, I think this is fine. He will search for school. He will search for the school. He will not, okay. he may or may not find the school. Okay, he may or may not find the school. Assume the school is not there. School is not there. If the school is not there, the table in the shared buffer is not there. He will go to the data file. He will go to the data file. From data file, school is fetched to the shared buffer. Okay. School is fetched to the
Uh-huh.
shared buffer, and then school data is returned to the user. Okay, he will return it select star from school. Maybe next time when he again put this query select star from school, he will again go to this shared buffer. Now school is there because just now we have fetched it. So it should be there. 99% it should be there, but it can be overwritten. So assume the school is there. He will directly read it from the shared buffer and will return to the user. Okay. So which person is doing this task? This backend process, or you can say the Postgres process is doing all those tasks. Okay. Will Postgres
Uh-huh.
process is doing all those tasks. Okay. Okay. So now I think first what happens, it reads to the shared buffer. From shared buffer goes to the data file. Okay. Postgres
And
process.
yeah, I just have a doubt. You just said the shared memory as a cluster. Why it is that? Why is it so?
Yeah, I will come
You
to that.
said it is.
I'll come to that.
Yeah.
I'll come to that. Okay. So now this is clear, right? So data
Yeah.
request go to the shared buffer, go to the data file. From data file, it comes back to the shared buffer. Okay. So next
Uh-huh.
is
Uh-huh.
next is assume another query come up. Now it is not select statement. It come up update school set grade is equal to 10, where
Uh-huh.
roll number is equal to 1. Okay, such query came up now. Okay, where update school set grade is equal to 10. So use this Postgres process again. User request is this. So Postgres process will again go to the shared memory. Will go to the shared memory, search for school. Assume school is there. School is already there in the shared buffer. He will put an update on this query. Set grade is equal to 10. We are rolling. He will put an update on this query. Now he'll put an update on this query, and then now this update will be written to the data file after some time. Okay, based on different conditions. Actually, we'll discuss on those conditions. It will return to the data file later on, but first we'll update the shared buffer. All the changes are first go to the shared buffer. Now this is a change that has occurred in the database. So now database has a property to record all the changes what is happening in your database. Now this property is not the feature of Postgres database. This is the feature of the RDBMS database. Okay, this feature is the RDBMS database. This property is the feature of RDBMS database. So any RDBMS database will record the changes that is happening in your database. Okay, so this is needed for your backup and recovery purpose. So what will happen? I made some change. So what I will do? I will input the old value. Assume the grade was 9. Now the grade is 10. Okay, and I will insert row ID. Okay, the row ID of the row, and I will say 9 and 10. So a record of change. I say what I say, a record of change. A record of change will be inserted into the val buffer. Okay, so the record of change will inserted into the val buffer. Okay, so now this will go to the val buffer. So this is a record of change. This is known as val buffer, where it is recorded. Okay, so val buffer full form is write ahead log. Okay, it is known as a write ahead log. Short form is val. Okay, the full form is write ahead log. So data will go to the val buffer as a record of change. A change record will go to the val buffer. Keep an history of the all the changes that are happening in your database. Now later on, after some time, this val buffer will write to the val segments. Okay, after every commit, to make the changes permanent, because this is buffer, right? This can once your server goes off, this will go off. So it has to return to the val segment after some time. Okay, so this first return to the val buffer and after some time is write to the val segment. So now you can relate all these files, what these files are doing actually. Okay, you can relate to all these files. So data files is containing the data, val is containing the changes that are happening. So val is writing to val segments. Okay, now comes this archive val. Okay, now comes this archive val. Okay, this process array is all the processes that are there in your database. Okay, all the processes like your background writer, checkpointer, auto vacuum, val writer, stats collector, all these processes are there in the process array. Now comes to the point of val. Okay, archive val. Now what is this archive val is? Let me clear this. What is this archive val is? So this val segments, which is what happens, what now how this val is being managed in Postgres is size of the val file is 16 MB. 16 MB is the size of the val file, correct? Now this 16 MB, it will keep, now once this 16 MB is full, it will write to a new val segment. Okay, so this is referred as val segment, not as file, but actually it is a file only, but this is referred as a val segment. So first it write to a, I'm sorry, so val segment, it will write to 16 MB of val, 16 MB, then it will switch and start writing to a new val file. Okay, it will start writing to a new val file. So 16 MB, 16 MB, 16 MB, and this will keep on writing and up to the size of 1 GB. So total val file size is 1 GB. Total area allocated is 1 GB. Okay, after 1 GB is full, it will start overwriting the first file. Okay, so you can divide 16 MB to 1 GB. So you can say almost 64 files would be there. I think so. Okay. Almost 64 files would be there. 64 val segments would be there.
Okay. I think 640.
640. Let me check.
So this segments are kind of portion type, right? It's like a small segments like 16 MB, 16 MB, 16 MB, right?
Segment the file only. Yeah, it's just a file. 64 files. Yeah, 64 files. If you divide 1024, 1 GB, right? 1 GB total space. So 64 files would be created. So this is a file only. 16 MB files, small 16 MB files. Already created, and that is the 1 GB. You can change 1 GB actually. You can change this limit, not a problem. So till 1 GB, it will keep on writing it. After 1 GB, it will start overwriting the first file. Okay, this is clear. So because it is going to overwrite, we need to have some storage, right? We need to have some storage for these files. So these file, when one well segment is full and it switches to the next well segment, what will happen? It will also copy that val segment to archive val. Okay, archive val are the offline val files. They are offline val files. They're just the storage, a kind of a storage for val file, because val files get overwritten. It should not be a problematic, and it should in case your database recovery is required, you cannot override the files. So that's why there are archive val files. Okay. So there is data files containing there is a val segments containing the changes that are made to the database. So val segments from val buffer to val segment. Which process writes it? This process writes it. Val writer. Okay. Val writer will write. Val writer will write it. Okay. Val writer will going to write it. Val
Hello.
is going to write it. Okay. And from shared buffer to data files, this process, background writer will going to write it. Okay. Then there are some error log files, some log writer, some files for error and some all those stuff. There is a files. Then there is from val segments to archive val. This process is going to write, that is known as the archiver process. So this process is going to write it. Okay. This process is going to write it, that is known as the archiver process. Okay. So now now next important thing is understand is now this is clear, the basic architecture is clear now, still we are not done with the architecture. Whatever we told is clear to you.
Yeah. You're going a bit fast. Can you please go a bit slow?
Okay, sure. Okay. So next is auto vacuum. Okay. Auto vacuum is one of the process. Okay. So now how let me tell you what happens when a update or delete happens in Postgres. Okay. Okay. So now what happens is you can see the notepad, right?
No, I don't see.
Just now assume there is a small table. Okay, only 2 rows. I said update school set grade is equal to 11, where roll number is equal to 1. Assume this is the this is a kind of this is the position. Okay, this happens. Now what will happen to this row? Okay, so you might be assuming the grade 10 will become 11, right? Straight. Okay, but in Postgres something different happens. Like in the table, like for users it is definitely 10 becomes 11, but internally what happens is Postgres never updates any row. Okay, it only deletes and insert. He will make this row as a dead row and he will insert like this: 1 ram 11. Okay, so it'll become 1 ram 10 becomes a dead row. He'll insert a new row with 1 ram.
Okay.
Assume this row is deleted. Okay, so 2 Peter, maybe I say it from school where roll number is equal to 2, but actually this becomes a dead row. This is marked delete, kind of a marked delete, you can say, marked for delete but not actually deleted. Now why this occurs? Can you tell me?
Like if I want to recover, if I want to do any rollback or something, it will be convenient for me.
Okay, what else?
For me, this
Can
one.
you relate to it to some other things in Oracle maybe?
No.
Something like something in Oracle is there.
No, I'm not getting any Oracle related part now.
Okay, so where does the old get data goes whenever we delete anything or whenever we insert anything? Till the transaction is not committed, okay, or even after the transaction is committed, the old data stays in undo table space. Why?
Yeah.
Why? to provide us a read consistency. In case there's a long running transaction, we want the old data, then to get the to get the old data, we get the data from undo, correct? We get the data from undo. So that is the similar thing happening in Postgres, but in a different way. Okay, in Oracle, what happens? The old data, whenever you update or delete, the old data goes to the undo, stays there till the commit happens. First of all, stays there till the commit happens. And second thing, the second was some parameter, like there is a parameter which stays there by default is 15 minutes. Even after the commit happens, it will stay there for 15 minutes, because there can be some transaction that is running in the database, that is looking for old data, that is started before that transaction is committed. So it is looking for that old data. So for that reasons, undo data was there. So similarly for here as well, to maintain the read consistency, first of all, till the time commit doesn't happens, then definitely this data is needed anyways, because maybe rollback can happen in future. After commit also, the data will still there, data will be still there in this in this table, in the form of dead rows, till the time all the transactions that are started before it are committed, are no longer there in the database. Till the time this data will stay there. Okay, well, I'll tell you an example. Okay, just give me 1 minute.
Yeah.
Any doubts?
Yeah. Yes. Yeah. We can go to the same notepad again. Same session.
So what is happening out here is that this row has becoming a dead row. Okay, so I am deleting, I'm updating this row, so this become an active row. This I'm deleting, this become a dead row. Okay, now what, how you will see now, which now there is a process known as auto vacuum process. So vacuum, you understand, right? Vacuum process, vacuum in English is who is cleaning all the dirt, right? So in
Yeah.
Postgres also, vacuuming is something which is cleaning all the dead rows. So it is cleaning of all dead rows. Okay, so it
So
is,
it will have like some
let me complete.
some.
Let me complete. I
Yeah.
will complete, then you can ask question. So clean up
Yeah.
all clean up of all dead rows. Okay. So now the question comes that when it should clean. First of all, this process is almost continuously running in the background. Second, the question arises when it should clean, when's the right time to clean. Okay. So what will happen is, assume every transaction in the database has an ID. Okay, in Postgres. So assume this update, we put this update, right, where roll number is equal to 1. This update was a transaction ID 100, assume. Okay, so this transaction ID was 100, which did this update. Okay, and there are a lot of transactions running in your database. Some transaction ID should be 95 9. So this transaction ID is always in a serial order. So after this transaction 100 is after somebody initiated one transaction and then did this update, then this transaction ID is 100. Maybe next minute some other executed one like make a connection and started one more new transaction. That ID would be 101. Next would be 102. So always in a sequence number. So practically it is not 100. It's not a small number. It would mean a bigger number only, because there are thousands of transactions that had happened in your database. Okay, so the number can be in thousands and millions as well. Okay.
Okay.
So assume this 100 transaction ID is there, which is updated this. Now there can be transaction IDs running. There can be transaction that was started before that, right? 100 also that is still running, not committed. So what is the age of a transaction till the time commit has not happened, right? So there can be some transaction with transaction ID 95, 98, or maybe 99. Then after this 100, there can be some transaction of 105, 110, 120, 130, right? This transaction keep on running, right? Now this the transaction which has made this rows at dead is the transaction ID 100. Now auto vacuum will keep on checking that whether there are any transactions that are older than 100 in the database. If there are any transaction that is older than 100 in the database, it will not remove this row. Okay, this row will be removed only if all the transaction IDs before 100 were committed or rolled back. Okay, so that means the transaction are closed. All those transactions are closed. Once this transaction are closed, that means this row is not needed in any new transaction, right? In any new run, this row is not needed, so it will delete this row. Now this deletion happens permanently. Okay, now this auto vacuum will permanently delete this row. Okay, once all the transaction older than 100 is committed or rollback, that means you can go ahead and delete this row. Okay, now this is the logic of deletion of any dead row in the database. Now which process does this? Auto vacuum does it automatically. That is auto vacuum. That's known as auto vacuum. There can be some scenarios where auto vacuum not able to do it, or maybe you have stopped the auto vacuum, because you can stop the auto vacuum as well. Okay, by default it is running, but you can stop it. So you can also vacuum any table with the command of vacuum. Okay, with just the command of vacuum, you can even clean up all these dead rows with the help of vacuum. So there can be auto vacuum and there can be manually vacuuming as well of your table. Okay, so this is the vacuum major processes of your database. Now you can ask your questions.
Yeah. This, for example, transaction ID 100. And for example, it's a statement it generated transaction ID, right? For example, on the 99th one, if it is running any update, for example, any one more update is going on. So when I do the auto vacuum, so to clean up the dead rows, so the transaction ID 99 and 100 should be committed to clean up all the dead rows, right? So
Right.
like 96 and 97.
Right. All the
And it should be
transactions.
committed.
Yeah. So whichever transaction created this dead row. Okay. All the transaction IDs before that should be closed before this dead row is removed. Otherwise, it will stay there. It will stay there.
Transaction ID, you mean select is also transaction in this one?
Yes, select is also transaction ID. Yes.
Okay.
Right. In the same way, what happens in undo? If you're not like whoever is an Oracle DB, understand the concept of undo. What happened in undo? After commit, we try to keep the data for 15 minutes. Right. Now we are not keeping it for some time here. We are not taking a risk of time. Okay. Otherwise, after 15 minutes as well, if the data is, we are not getting the data of that particular transaction, then this error occurs. Snapshot to old error.
Yes.
Right, this error occurs. Now we are not taking a chance of this error in Postgres. So Postgres is not even taking a chance of this error. He's saying the rows will stay there, maybe stay there for hours, minutes, or maybe days if there are older transactions still running in your database, or older select statements still running in your database. So he's not going to take a chance. He's saying the data will still there if the older transaction are still running in your database.
But this doesn't make overhead on the database, like any size growth or something which will affect the performance.
You can say that. But this is how it is designed. There can be some positives and negatives definitely attached to every feature. Okay, so this is how it works. Okay, so this is how it works. So in this way, I am covering all the basic architecture for your Postgres. All the processes that are in your Postgres. So we understand what is data file, how the data is, and what's the data file is, what is I'm telling you about data files, more about these things as well. What is Val segment? So Val segment by default size is 16 MB. It will keep on incrementing and keep on moving to the next val file till it become 1 GB. 64 files are created. After that, it will start overwriting it.
Okay.
First file. Okay, so it's not that it will reach to the 64. You can configure it way that it reaches to the 64. Okay, generally what happens, we have parameter like that after 5 files itself, I don't remember the exact parameter name, but after 3 to 4 files automatically start overwriting the first file, because val segment is already creating a copy in the archive val file. Okay, automatically creating a copy. Okay, so max size is 1 GB. If it's stuck in 1 GB and this val file is not creating the archive file, so it might hang because it cannot override the val segment till the time it is not copied to the archive val. Okay,
Okay.
archive
Okay.
is enabled. Okay, so this is error log files. Log writer is writing to the error log files. Archiver is writing to the archive file. Stats collector is collecting the statistics of all the tables and objects and other things. Okay, val writer is writing from val buffer to val segments. Auto vacuum, we understand what auto vacuum is. It is just auto vacuum is cleaning of the dead rows and also does one more thing. Okay, it collects the statistics as well. Okay, auto vacuum collects the statistics as well. Check pointer, now check pointer is a trigger. Okay, so when does the val buffer write to the val segments? It writes in every commit. Whenever a commit occurs, val buffer will push the data to the val segments. Okay, it will push the data to the val segment whenever a commit occurs. Okay, but from the shared buffers, when it will write to the data files, shared buffer will write to the data file at every checkpoint. Okay, the checkpoint is a triggering event which occurs almost every 5 to 10 minutes. Okay, these is all parameters. The parameter default value keep on changing with each version, but I think the default is 5 minutes itself. Okay, so shared
Uh-huh.
buffer will push the data to the data file at every checkpoint. So every 5 minutes, you can say the data is pushed from shared buffer to data files. And who is writing? Background writer is writing. Okay, so this is the basic architecture for your Postgres. Now, one more thing is database cluster. I talked about database cluster. Okay, so I think from any database background you are, it is the same concept. Just like in SQL Server, there's a concept that they are they are chunk of databases sitting on one instance, sitting on like one memory structure. Similarly, in Oracle also, there is a concept of multi-tenant architecture. Okay, so it's kind of multi-tenant architecture. In MySQL also, there is a similar concept. Okay, so there are multiple databases which is identified as one cluster. Okay,
Uh-huh.
which will sit on this shared buffer, which will keep on accessing this shared buffer. So all these databases will link to this one shared memory and one post master memory. Okay, so this is one database cluster. We will create one database cluster. By default, there would be, I think, three databases automatically created in this database. Three database will automatically created in that database, and you can create your own database in that cluster, and all these databases will be accessing one shared memory and one postmaster process. Okay, so all these
Okay.
databases will access this shared memory and the postmaster process. This is known as the database cluster. So don't refer cluster in general terms means is multiple machines. Okay,
Yeah, yeah, yeah,
but
yeah, you're
but
right.
in Postgres, cluster does not mean multiple machine. Database cluster means collection of databases. Okay, there is no multiple machine concept in Postgres. It is not advanced. If you're an Oracle DBA, don't compare with rack. There is no such rack thing in Postgres. Yes, there is a standby in Postgres, just like standby in Oracle is there. There are a lot of things which should compete, but rack still not there. There is nothing in competition to rack in Postgres as
Uh-huh.
of now. As of now.
Okay.
Okay, so this is the architecture. Okay, I think we already covered this. Postmaster, by executing this PGCTL utility.
What is this utility?
Okay, so PGCTL. Uh, Now, PGCTL is a utility that will help us to start and stop the Postgres cluster, database cluster. Okay, so we can start and stop our database cluster with using pgcutl. Okay, so what the postmaster does is, whenever receiving any, if you see this third point, whenever process whenever it is whenever receiving a connection request from a client, it starts a backend process. I think we already discussed. And then the started backend process handles all the queries issued by the connected client.
Mhm.
A Postgres server process listens to one network port. The default port is 5432. This is the default port. Definitely you can change the port, kind of the port number. Now backend process, I think backend process we discussed. I already summarized everything. Okay, we are just going to quickly we'll go to these points and then we'll end the architecture. So postmaster will create one Postgres process for each session. For each session, that will communicate with the client. Will communicates with the client and will fulfill all its needs. Okay, fulfill all its needs. Allocate some space in the shared buffer. As it is allowed to operate only one database, you have to specify a database. So you cannot have multiple connection to the database cluster. One connection, one database. Next time you want to connect to some other database, you have to make a new connection. Okay, database might be sharing the cluster, sharing the memory, sharing your files, everything, but they are different entities. Okay, logically they are different entities, so you cannot connect and mismatch, or maybe connect within databases. Like in one database you are calling other database. This is always not feasible. Okay, only an exceptional, like if you want to just like you are in Postgres database and there is one more database name as HR, assume, and you want some object from HR, then you cannot create a join condition and create a fetch the object. You can create a DB link. Okay, you can create a network link where you can fetch the data from the any other database, but not through any inner join or outer join kind of features. Okay. So PostgreSQL allows multiple clients to connect simultaneously. The connection, there is a parameter known as max connection that will limit the number of connection that is made to the PostgreSQL database. By default, it is 100. That is very low value actually. That can be higher. Now this vacuum process, the vacuum, I think we discussed. There's a separate chapter for vacuum as well. Over there, we'll also discuss in detail. Okay, so vacuum is something which is used to vacuum your object. So that means clean up of all your dead rows. Okay, you can manually vacuum. So these all process we discussed. Background writer, writing from buffer to the data file, check pointer, triggering event, auto vacuum, background worker, logical replication, val writer, writing from val buffer to val file, statistics collector to collect the statistics. Okay, an archiver to write, copy from val buffer to archive file. Okay, so this is all about the shared memory architecture. Now in addition to shared, there is a local memory. Shared memory means is that is shared among all the user session. Okay, among all the user session there would be some shared. Okay, there will be some shared memory architecture. Now we have to cover the local memory architecture as well, maybe in the next chapter.